Hello, I'm Sam Underwood,
And I'm Graham Dunning.
and this is the Mammoth Beat Organ.
The Mammoth Beat Organ is a mechanical, modular, acoustic musical instrument designed by me and Sam to be played by two players at the same time. It's partly playable and it's partly programmable.
One way to consider the Mammoth Beat Organ is like an inside-out fairground organ. So whereas in a fairground organ you have things like a drum sequencer and various pipes that can be played by things, in our case all of that is exposed and is accessible. So you can not only change the sequences of things, but directly manipulate the sounds that they create. So if you don't like the sound of a snare drum, or you want to change the pitch of an organ pipe, you can just do that by sticking your hand in to the workings of the machine, and that will alter the way that it sounds. The air sequencer module that we have has 8 outputs. Each of those outputs has a valve, and then for each of the valves there is a wheel that turns with 16 steps, like a 16-step sequencer, for which it can be either on or off according to the position of a little slidey thing that we can change in real time. So if you want the valve open, you slide it into one position. If you want the valve closed, as it passes, you slide it back into the other position. Through that method you can create a sort of sequence that goes around across all of the 8 valves, and then how often that passes in one cycle is determined by which of the cogs you choose to engage on either side of the machine. So you can have them running at half speed and I think 2 to 3, and we have quite a number of complex options that can happen rhythmically then.
A different way of looking at the Mammoth Beat Organ is that it's like a sampler sequencer, like a Groovebox 303, but it happens to be mechanical and acoustic version. Me and Sam are both used to producing electronic music, so we've experienced performing live with drum machines and that sort of thing, and it's a different type of performance when you have something that's programmable and kind of runs by itself. So another example of that is the rhythm unit. It's essentially used for most of the drums and percussion. So it consists of 4 different sections, and each one has 2 beaters on it. And those beaters are activated by placing differently shaped cams, throwing down the cog onto the drive shaft, and that makes the cam lift and then drop the beaters. If you think about it as a step sequencer, it's kind of like pausing one of the sequences while all the rest of them carry on running. So you can actually get quite interesting phasing things just by starting and stopping different ones at different times. Quite often we use normal acoustic drums. Sometimes we would use glockenspiel bars or something like that. Sometimes we use other small percussion. There's a little miniature hi-hat, there's a cowbell, various other things. The different cams that you can put on the unit are divided up by different numbers. So some of them are in patterns of 3, some 4, 5, 6. We've got quite a lot of 7-time cams. Because of the way the system works, they're all interchangeable. So it means you could have, for example, a drum playing a 4/4 beat and then put something on in a division of 7 over the top, or 6 or 3, or whatever you want it to be. So you can get quite interesting patterns. We found after a while that was slightly limiting, so each of the different sections can now have 3 different speeds on it. You can play them all so that they all run at one cycle together, or you can gear them differently. That means that you can do kind of polymeter and polyrhythm quite easily as well. It gets really confusing quite quickly, but that's part of the joy of this machine, that it kind of has a mind of its own, a life of its own, and some agency in the way that it makes the sound. Me and Sam had known each other for a number of years, socially and to make music. We played together in an improvising trio with Colin Webster on saxophone. Sam plays tuba and I play turntable. We've both seen each other play quite often as well and liked each other's approach. I think our interest in different types of music has quite a lot of crossover as well. So it seemed natural that we were going to work together at some point. So we decided in, I think, 2017 to throw some ideas around and see what came out. I went up to Sam's and we made some contraptions with bike wheels and things. Decided then it was worth pursuing, put in for some Arts Council funding, and then that led to our first show with the Mammoth Beat Organ, which was at Supersonic Festival in summer 2018. So quite a lot of our research in developing the machine was into fairground organs, player pianos and barrel organs, these kinds of mechanical music playback systems. And it's quite interesting that really mechanical music went out of fashion at the start of the 20th century as recorded music became popular. And that meant that really fairground organs never got the opportunity to be experimental. There's not really very much avant-garde music written for mechanical instruments. Even nowadays, most of the things that you see of mechanical instruments will be someone doing a cover version or something like that, and we wanted to really exploit the opportunities that it provides by having a mechanical instrument to make music that you wouldn't be able to make by other means.
Yeah, some of the ways that we go about that are similar to how maybe a musician might use extended technique on their instrument. So things like organ pipes that are overblown or underblown to create different timbres and tones. That's quite an unusual thing to be doing in a mechanical musical setting, because what you tend to do is try and build a thing that functions as it should at all times. We also incorporate quite a lot of the sound of the machine itself in what we do. So to some degree we don't have a choice because we're not the best engineers in the world, so you get quite a lot of noise off some parts of the machine like the cogs and so on. But also we extend that with by having sections that where we perform by putting stuff into the machine itself, so directly dragging stuff on the drive shaft, or there's a section where we put playing cards into the cogs so that it creates a very loud chatter and just amplify really and bring to the fore the noise that the machine itself makes, which again is stuff that normally you're trying to hide or get rid of as much as you possibly can.
One of the things we wanted to do when we started out with this project was to make something which was ongoing so that we could keep developing it and adding new things as it went along. So that's what we tend to do when we have a show, is we'll meet up at Sam's, set up the Mammoth Beat Organ and not only rehearse with it and practice playing the machine, but also develop some new parts for it as well. So a good example of this would be the glockenspiel bars section. So we added these into the rhythm unit so that it could play melodies as well as percussion, but also I've added in this kind of automated section with two rolling barrels of glockenspiel bars which kind of go in and out of phase as the beaters are playing. So it creates this kind of unusual, almost generative music which we then add different components to.
Graham and I have never made anything quite of this scale before, so it's been quite challenging. Something that we've made before might be mechanical, or on my side just an acoustic musical instrument, but to bring those two together and then scale them to the scale that the Mammoth Beat Organ is has been quite challenging. Luckily, I think those two skills work really well together. So I'm really good at designing acoustic musical instruments and acoustic systems and how to get the most out of it sonically. And Graham's really good at working on the mechanical side and the systems side and how you get it to play and function as a musical instrument, or a sequencer or whatever. So there's a number of overlap skills there that when you bring them together create something that's working out pretty well. And really when we perform live, what we're trying to do is expose all of that understanding and the systems design and how we create interesting acoustic sounds to an audience in as direct a manner as we can. So when we first played, as I mentioned, that was at Supersonic Festival, and that was on a large stage with microphones over the top, and it was quite difficult really to get across the way in which we were making some of the sounds. And we've strived since then really to work in a smaller environment, acoustic environment. Probably our best gig to date was at Torfest, where we were rammed in this little room in a pub. Everybody was right on top of us. They were putting their pints on the machine as it was playing, all sorts of stuff like that. But the beauty about it was that they could really see how much effort we were putting in, what bits weren't working out quite right. They were right there able to see it in all of its glory and all of its failings. That serves to provide, I think, a really engaging performance, something that Sarah Anglis has referred to as a coupled performance, where you really get a sense of performer does this, outcome is this, and you're in there with them in the moment.
Early on we were wondering about whether to introduce kind of pickups and different kinds of amplification, partly because some of the bits of the system are a lot quieter than others and the machine itself makes quite a lot of noise. But actually when you're seeing something live right in front of you, you can kind of hear where the different sounds are coming from on the machine, and it's almost part of the listening experience is to focus on which bits are making what sound, rather than having everything at perfectly kind of mic'd, amplified volume.
And we've generally had really good response to the Mammoth Beat organ when we've played live. They can see as audience members that we're absolutely going for it. But there's quite a lot of effort to play. There's various things that you're having to lift into place and then make sure you don't get your fingers trapped and so on. So there's a lot going on, and it's it's something that is an unusual type of performance to see. I think that's generally gone down really well. Of course, if you move into the online realm, as we have done with some of our videos of the Mammoth Beat organ, then it's not everybody's cup of tea. We get quite a lot of "this is not music" or that sort of stuff. We're pretty used to that. That's all cool. When people are there with the machine in a space, it seems to go down really well.
So as well as the live performances, we wanted to use the machine for different things as well. We're kind of considering using it as an installation piece at some point, but also the other main thing we want to use it for is for recording in the studio. So I released an album on a label called Front and Follow in February 2019, and it really gave us the option to think about how to record it and which elements to use together, think about making kind of shorter pieces rather than playing a whole 40-minute set with everything that it can possibly do. It's also quite interesting to release something just as audio only. The artwork for the release didn't have any pictures of the machine or anything like that even, so really detaching it from how the machine is made, I think that gives it a different dimension really, and you get a real feel for how unusual the music that you can make with this machine is, which is one of the main goals for this project really.
Hello and welcome to my studio. I wanted to take you through what I built. I decided to set about building a siren disc organ, so essentially a 200-year-old synthesizer if you like. So this system works with a spinning disc that normally spins at great speed with a high pressure air system that blows air through a series of holes, and the frequency of those holes passing the airflow creates a note. And the more holes there are per ring, because you tend to have a series of concentric rings of holes, the higher the pitch. The pitch can then also be altered by increasing or decreasing the speed at which the disc spins, but the relationship, the interval between the various notes on a disc always remains the same. So as I say, this normally has a high pressure air system and a very straight running disc. We don't have a high pressure air system. We have a very old, antique in fact, blacksmith's bellows that I push constantly with my foot. And we also don't have anything that runs very true on the Mammoth Peat organ. So it was quite a challenge, because those elements, getting the high pressure air through the disc at very close proximity, is what makes the siren disc sound efficiently, so loudly really. So, and in the context of the Mammoth Peat organ, it's important that we try and get each of the elements playing as loudly and acoustically efficiently as they can, so that they can play against, say, the drum module, because everybody knows drummers are noisy. So I decided that quite early on, having started on paper and then quickly got into some quite terrifying tests with me blowing through things as they're spinning at great speed, and then these kind of versions that were chattering all over the place as they span at great speed, I decided that it needed to be abstracted from the main drive system that we use, for a couple of reasons. One is that it meant I could use more engineering grade parts, so straight bar instead of threaded bar, and then a sort of better coupling system using belts and stuff like that. Also meant I could gear it, and then the way that it joins the module I also adapted from how we normally do, because we normally use cogs and they chatter quite a lot and make quite a lot of extra noise, that I tried to take away from this module so that it could make more noise than in the musical sense than it does in the just noise of the machine sense. I got pretty successful results out of it. There was then also the opportunity, because I don't think Helmholtz had a laser cutter, there was the opportunity to build a series of discs to test, so unusual shaped holes and stuff like that, leading to a final solution which again seemed to give greater amplitude, which is good, but still I wanted a little bit more. So I had a little think about what could be a historically accurate amplifier, something that you might have been able to use for amplification 200 years ago. And so that led to what you'll see over here now. So that's the siren disc module. As you can see, unlike a siren disc that's normally built into an organ of that type, there's a lot more access to the disc itself and the drive system and even the little clown horns as well. So you can really manipulate the sound in ways that you couldn't do if it was inside a normal siren disc organ or bigger machine. And there's obviously lots more I could have done and lots more that I intend to do. One of the things that I would like to do and tried a little bit was having these valves so that you can have a kind of keyboard way of playing it rather than relying on the existing sequencer or having it always on. But yeah, I'm pretty pleased with the outcome so far and looking forward to getting it all together sometime with Graham's new machine, making some noise.
Part of the decision for what to make for a new unit for the Mammoth Beat organ was having to think about what would augment the kind of sounds that we already make. We use the organ pipes quite a lot, we use the drum sequencer quite a lot, and we have various other instruments that we use, like a turntable and a tombola. There's a intonamori sort of hurdy-gurdy instrument. But we don't really have anything that plays bass, apart from a couple of bass organ pipes. And we don't really use any plucked strings in the setup. So I thought it would be nice to make something that does both of those things, and decided to make a kind of automated bass banjo. Normally we'd go through quite extensive prototyping of a new module for the Mammoth Beat organ. But because of the situation this time, working in my studio in London rather than with Sam at his studio, I basically had to design the whole thing first, get some parts made, and then put it together. It's quite a different way of working to what I'm used to. So that meant that I basically had to put it together on paper first, make lots of diagrams, lots of drawings, iterations of different ideas, thinking them through drawing and seeing what would come out. I kind of struggle with 3D, thinking in 3D, so it helps me to draw things on paper, but really I need to see it in the physical space for it to make sense to me. So I also made a kind of full-sized maquette version out of cardboard to see how all the parts fit together. Once I was happy with the idea in diagram format, I kind of made scale drawings ready to convert to vectors in order to get things laser cut or CNC milled to get my own kind of flat pack Mammoth Beat organ module. Once I'd got all the parts delivered, of course, sometimes there are problems with these kind of things, so some of the pieces were much too big for my specifications, so they've been cut to inches rather than centimetres. A couple of the other parts I'd mismeasured, so I had to cut some extra holes for the bearings and things, which was kind of stressful because I can't really do anything with precision here. The way that I designed the system, it's kind of modular in itself, so each of the sections I could put together separately. So I put together, for example, all the cogs for the plectrum plucking section. I could test that worked first. I could do a basic test of whether it would actually work to kind of pluck things in rhythm, and that seemed to be working okay. But really it was a case of building the entire thing before I could check whether it was going to work as an actual banjo. All of the modules on the Mammoth Beat organ need to have some kind of on or off switch, so in this case it connects to the wheel, the cog which is inside the wheel unit, which is always rotating, and it has this lever which enables you to put a cog against that cog and drive the internal drive shaft of the unit. From there I needed to get horizontal motion from the axle into vertical, so it uses these two cogs with bigger teeth in order to do that, and that means there's a vertical axle which is turning, and I can engage or disengage both the plectrum section and the fretboard section in order to play or not play. So the way that the plectrum section works is it has 4 rotating hubs, and onto each one you can put different pluckers and different dampeners. This is something I want to explore more with further different options. At the moment I have these circles which are divided into 16 sections, so it gives you a fairly standard rhythm, but of course those could be divided up any way that you like, and in future I'm sure we will make some different plectrum rhythms and things. Then I've also started to make a few felt discs and a rubber disc which can damp the strings in different ways as well. The idea is that when a sequence is playing, you can introduce or stop different sounds either by muting the strings with your hand or by adding or removing different plectrum pluckers. Then a bit further up the strings, the kind of top half of each string, on each string there's one of these rotating fretboards. So without any frets attached, they will just freely rotate, not get in the way at all. But each one has 4 faces onto which you can put a plectrum. Each face is magnetic, so you can slide the plectrum into any position that you want to. So that means you could potentially set them all on the same location, in which case you are playing a different note than the open string, or you can sequence them so that as it rotates, that set of notes will change. The idea is that you can set a different sequence on the fretboard to what's happening with the plucking mechanism, and indeed you can start and stop them at different times, so you can change the patterns of one against another. The exciting part about one of these kind of builds is when you get to the stage where we're at now, where it's up and running and it's fully working, all the parts are tested, and it's a case of playing it and experimenting with playing it and seeing what it can actually do, what kind of sounds you can get it to make.
So this next piece is me and Graham playing together with his contraption and the siren wheel and drums. Obviously, normally that isn't done remotely, and his unit is also attached to the drive shaft, so we have something that's basically in time. It's been quite a task doing that bit remotely. And then we come on to the final video, which is a snippet from our live set earlier this year at Ideas of Noise Festival in Coventry. Thank you for watching.
it.